We've travelled to Paragon Rapid Technologies in the northeast, and they've just invested in a whole unit dedicated to additive manufacturing. We're going to find out exactly why they're so ahead of their game, how they're making these, and why they chose to purchase a HP Jet Fusion from Matsuura. Wow, this is going to be an education. Now, Roy, what's so interesting about what you do here is the fact that you can produce one part to up to 10,000. It's almost like automation with printing. Tell us about the process.
Yeah, absolutely. It's the flexibility of the process that allows you to not just produce what would traditionally be prototype, but then onto full-on production as well.
So where does it begin?
So it begins with the customer, obviously. At the very early stage, we'll work with the customer to create a product that is additive manufacturing orientated rather than traditional production methods.
Right.
So there's a distinct difference between what would be an injection molded part and a 3D printed part.
But it's quite good because you have a facility that you're able to cope with that, but you've still seen a requirement for this side of the business.
Absolutely. There's been such a shift in what people are now recognising as a production intent process. HP with this system have really taken it to the next level. You know, it's so much more fluid, and the interface with the user is much more productionised. Right,
okay, let's start at the first process then. CAD model into the HP over there, is that right?
Absolutely, yeah. So all engineers are familiar with CAD models. They'll send us the CAD data. We'll then take a view on that and recommend any adjustments that might need to be made. Once that's all finalised, then we'll zip the CAD over to the HP printer, set it up in such an orientation that it will give you the best quality of print, and then we program that into the machine and press go.
And so what are these called, and where do these come into it?
So these are the build stations. These are effectively where all of the parts are produced. So we've got an empty build station here, which would be filled with powder, and then...
Which comes from here?
Powder, absolutely. So it comes in bulk in these containers, as you can see. And then the powder from the bulk station is loaded into the cartridge through this system here. So this is basically a feed system. It not only loads the powder into the empty cartridge, but it allows you to remove the parts and the powder at the end of the process.
Right, so it's almost like a pallet system that you're using. So we often talk about keeping that spindle turning, but you're keeping that printer printing.
Absolutely, and it's all around production. It's keeping the printer printing, it's keeping the facility moving forward at any given stage. It's all about less user interaction, less manual labour, and more automation.
So once one of these goes into the printer,
Yep.
Then what happens? So it's full, it's ready to go, goes in, what happens?
Yeah, so then you go through the print process. So with the HP system, effectively what you're doing is you're introducing a powder and a resin, and through the system of introducing the two parts together under heat, that's where you get your solid part created directly from the CAD data.
And then from there, where does it go?
So from there, at the end of the build phase, it will be taken out, and then it's left to cool. The cooling period can be as long as the build period in a lot of cases, and once the parts are cooled, then they'll go back to the breakout station, where we can then start to remove each individual component.
And how many components are you looking to place within each?
Yeah, that's a very, very wide question.
It is actually. It depends on size.
Absolutely. It all depends on the size. So within your build constraint, a typical good production scenario would be to get 50 or 100 components in there. Anything larger than that, it's not to say that it's still not feasible, but it becomes less cost effective. Very, very small parts, if the printer's got the accuracy to pick them up, then it can compete with other existing technologies.
And accuracy is what you're looking at?
Yeah, so it's plus or minus 0.2 is the standard tolerance on the HP machine. It's not as accurate as you would expect within the injection molding process. However, certain scenarios would suggest that, you know, accuracy is not always the most important aspect anyway.
We often say application specific, and some people might require that, they may not.
Very
So
much.
from there, it goes into this stacking system if required.
Yes, so this is basically the cooling system. And again, this is very much aimed at production. So it's all about getting the hot print off the printer onto the cooling station so you can load the next set of builds up and get it printing straight away.
I'm fascinated. It is like a palette changer. It's automation within this world. From there then, there's some other options, and this is what Matsuura have provided you with. It's a full process. So we go over to the DyeMansion next.
Okay, so what we've got here is the DyeMansion power shot system. The two machines obviously look very similar. The main difference is the medium that's used within the machine. So the Power Shot C is effectively used to clean the excess powder away from the components before we put them through the post-processing DyeMansion system, which allows us to dye parts specific colours. So whether that's a stock range of colours or a relevant Pantone or RAL reference, we can, you know, really keep to the customer's needs with regards to finish and colour requirement.
Well, what's quite interesting about the helmet that we saw earlier is the fact that you've got the strategic lattice on the inside and then you've got that pattern on the outside. You cannot do this on some of the other machines that you have, is that right?
Absolutely, yeah. So with that lattice structure, what you're doing is you're introducing a very human-like interaction with the component. It's something that you can't physically injection mold or make through traditional tooling. That's really specific to additive manufacturing.
So there's beads in this machine as opposed to this one. What's that going to do?
So this will remove the excess powder from the parts. What this does is apply that soft-like surface finish. So this is giving you that production finish that makes all of the parts look consistent and the same. And again, this is what differentiates this technology from traditional prototyping-like technologies.
Well, we first invested in additive manufacturing technology 3 years through a technology called DLS. And that was really, we were just exploring the technology and just getting into the marketplace. But we saw a lot of the technology being advertised by Hewlett-Packard, and we had an opportunity with a client within the orthotics and prosthetics industry. And this was probably about 2 to 2.5 years ago. And we did research in the marketplace, and we had Matsuura and Hewlett-Packard come in and do a presentation. Did a great job, but fundamentally the equipment, brilliant on productivity and efficiency.
We'll come on to their service, but really I want to know what it was that made you go for this and what industries this is going to serve. How is it going to transform your business?
Sure, yeah. Well, in terms of our company, it was a natural step. I mentioned earlier about the DLS technology, and that gave us our first footstep. But this particular technology, it takes it up a level in terms of where you can access in terms of manufacturing. It's true AM. Previously, it's just been adoptive technologies, generically like 3D printing, but the powder efficiency and the efficiency and productivity of the machine really takes to the next level, which allows greater volume production.
Exactly, that's exactly where I was trying to head, is the production. What is it that this is capable of achieving for you?
It'll be different with different technologies, different industries. It's more around the profile of the work and the application. One of our focuses is technology, material and application, and this allows us to broaden the applications that AM can access. So it will be particularly the volumes of products, but being able to take advantage of design, flexibility, but it's the efficiency of the machines married up with which will be the HP and the Matsuura technology, but then it's the collaboration with Matsuura on the service side that really finishes that off.
Quickly, industries, what are you aiming for?
Industries, I could say all of them. Predominantly would be medical, but within that orthotics and prosthetics, also industrial products and some of the prestige automotive.
Steve, you're a customer to Paragon.
Yeah.
What is it that you require?
We require a product that's going to go onto people. This goes onto babies, and the parents of these that are putting these onto babies want something that's lightweight, it's breathable, it's easy for the baby to wear, and it's easy for the parents to use. These are worn all the time, so it has to be something that's robust, but it's comfortable for the baby. These are worn by people that walk and stand on them. So you've got very, very different forces on these, and we need a product that's got strength in all three directions. So in the X, Y, and the Z plane. We need something that's going to be flexible where we want it to be flexible, and something that's going to be supportive where we want it to be. So the products that Paragon are making for us using the HP machine are consistent, they're reliable, we know exactly the properties that we're going to get out of them, and we're confident that these are going to go onto our customers, and we know that they're going to work for them.
Okay, what is it that Matsuura have done for you in terms of the purchasing? Because it's not just the HP Jet Fusion, it's also the DyeMansion and how it all comes together, almost like a cell.
Sure, yeah, very much so. But it is linking all the chains. They understand the offering, they understand manufacturing from their other parts of the business. But really with Matsuura, you just got that level of engagement, that warmth, it was collaboration, it wasn't just supplier, customer, it was very much working together to look at the solution, but they get the end picture, they get the value of the combination of technologies. But also I feel they've got the infrastructure to service that and support you in application developments, not just in the equipment.
Goals. What are your predictions in 1 year's time, in 2 years' time? What do you want to achieve to get the best out of this purchase?
Well, we've got a strategic business plan, and the additive manufacturing cell and business unit is one part of 3 business units. But really in terms of true AM, growth-wise, we've got a 5-year plan to take that business unit to £5 million turnover. This would probably be just the start of it in terms of the actual selling the capital equipment, but we're looking for support from Matsuura and DyeMansion and HP to really add further machines, get scalability, but really get involved in the collaboration with the customers and just look at developing the applications to grow where AM fits.
We've seen the process now, but really I want to find out about the relationship that you mentioned
Sure.
earlier with Matsuura. You've gone for this because you felt like that you've got a warmth from them.
Yeah.
But it's more than that, isn't it?
Yeah, absolutely. Yeah, it was, well, first point of contact was level of engagement. They understood where everything fit, but you also got the warm feeling, and it's not just a warm feeling, it's the technical support, it's a service. We met at senior management level as well as technical engineers and business development, but it was that collective, almost holistic approach to where an understanding where the technology fits, but also know they're going to be holding your hand when if there's an issue or there's an application they're developing. Inevitably, it is cutting edge technology, so there will be some debugging, but they understand it and have the customers and the case studies that prove out what they support.